So now we're going to talk about arcs and angles in a circle, formed by the arcs and angles that are formed by these different segments that we're talking about in this lesson. So in this first example, we've got two chords. We've got two chords. So if I've got two chords, the chords are first of all making these two angles, or arcs, I mean. And notice this is not a central angle, so I don't know that these are equal. They actually are not equal. But I do know that if I can find if I'm given two out of these three things, I will know the third one, or be able to solve for the third one. So in this case, I've got angle 1, which is congruent to this angle, and supplementary to the other two angles, because they're on the same line. So if I know two out of the three things, I can solve using this formula. The measure of angle 1, one of the angles inside the circle, is equal to the sum, or the average, of the two arcs. So let's call this arc X and this Y, divided by 2. So it's just the average of the two arcs. Okay, so they don't, if it's a central angle, you already know how to find it. If it's an inscribed angle, we know how to find it. But if it's not, how do we do that? Well, we take the average of the two arcs. Okay, so let's try one. We've got this example right here. So I've got two arcs. I've got these two arcs, 40 plus 90, 45 plus 9, 46 plus 90. Okay, let's just start this one all over. We've got measure of X is going to be 46 plus 90 divided by 2. Well, 46 plus 90 is 134. 134 divided by 2. 134 divided by 2 is going to be 67. So that measure, that angle, is 67 degrees. Okay, so that's how it works if you got two chords. Now what if I have a tangent and a secant? Tangent and secant. Now it's not going to be the average of the two arcs. Notice if I stop here and here, I've got two arcs. I've got an outside arc and I've got an inside arc. Both of those are inscribed basically by these two endpoints. I've also got a piece that I don't know, isn't made by that arc. So we've got basically three different arcs on this circle. Well, this formula that I'm about to give you works for if I know these two arcs, and then I'm solving for this angle. Let's call this P. So angle P. In order to find measure of angle P, I'm going to take the difference of these two arcs. So the outer arc, X minus Y, divided by 2. Instead of adding them, I'm subtracting them. A couple problems you might run into with this. What if I'm given this arc and this arc, and I need to find the angle? Well, think about it. You know all the arcs add up to 360. So if you know this arc and this arc, just subtract their sum to get this, and then you can use the formula. There's an alternate type of problem here, and that could be if you have a tangent. Let's say you have a tangent and you've got a secant going like this. Well, let's make this your X. Well, there is no Y. There's no inside arc because the point of intersection is on the circle. So that means Y is 0. And the angle P would be whatever this angle is. So in that case, P is going to be X over 2. So in that case, it's kind of like an inscribed angle. And pretty much that's what it is, an inscribed angle. Okay, let's see if we have any examples to go with this. Okay, here I have a tangent and a secant. I know that this arc is 35, and remember I just said, and the arcs we need are these two arcs. The arcs we need are these two arcs. But I don't know this arc. However, I can get that arc by just saying, well, 170 plus 35 is 205. What's 360 minus 205? That's 155. So now I can use my formula. This is 155. So it's the outer arc minus the inner arc divided by 2. So X is going to be the outer arc minus the inner arc divided by 2. 170 minus 155 divided by 2. 170 minus 155. Divide that by 2. 7.5. Did I do that right? So it's going to be 7.5, the measure of x, because this is difference is 15 divided by 2 is 7.5. Okay, so that's how you do a tangent and a secant. Next we have two secants. And I'm going to ask you to go ahead and ignore this right here. So we're not going to worry about that. We're going to make this angle 1. Outer, inner arc. So the formula for this would be the same thing. Measure of angle 1 is going to be x minus y divided by 2. And again, you'll have to remember, if you're not given x and y specifically, you will be given enough information to find out what they are. You might be given these two arcs or something like that. But you should be able to find out what they are. So the example that goes with that would be this one. No, two secants, sorry. Two secants would be this one. So the example for that, I'm given the outer arc, I'm given my inner arc, and I need to find y. So y is going to be the outer arc minus the inner arc divided by 2. 110 minus 30 is 80, divided by 2 is 40. So that would be 40 degrees. Last, we have two tangents. And guess what? It's the exact same formula. Make this angle 1, this x, and this y. It's going to be x minus y over 2. Okay, so the problem we're going to do is this one. Now, what's wrong here? I know the inner arc, but I don't know the outer arc. But I do know that handy piece of information that these two add up to 360. So if I do 360 minus 140, I get 220. So I've got x is going to be 220 minus 140 divided by 2. 220 minus 140 divided by 2. So that would be 80 divided by 2, which is just going to be 40. Okay, so let's see if we got any practice problems left. Just one. We've got a tangent, two tangents. So this two tangents looks like, why don't you pause the video, try the problem, and then come back. Okay, so I'm looking at this and I think, okay, I'm solving for an arc now instead of an angle. So in the problem, in the formula, I know this. I don't know one of these. Which one don't I know? The outer one. So this would be like your outer minus your inner. So 70 is going to be W minus 110 divided by 2. Multiply both sides by 2, and you get 140 equals W minus 110. Add 110. Add 110. And you get 250. W is 250.